Hello, my name is Barbara Andrews, and this session introduces the moment when a trained model becomes actionable in real time by deploying a model to a managed online endpoint in Azure Machine Learning. You create a scalable HTTPS API that applications, dashboards, or services can call to get instant predictions. Think of scenarios like a website that recommends products the moment a customer visits, or an app that checks fraud risk as a transaction happens. Managed online endpoints make this experience possible, handling deployment, scaling, and endpoint management for you so your model can deliver fast, real-time intelligence whenever it's needed. Managed online endpoints in Azure Machine Learning enable real-time inference. An endpoint is essentially an HTTPS endpoint that an application can send data to and receive a prediction almost immediately. The core idea is that a client can send individual data points to the endpoint, and the service returns a prediction representing real-time scoring of individual records. The key advantage of managed online endpoint is that Azure Machine Learning manages all the infrastructure behind the scenes, such as scaling, provisioning, and maintenance of compute resources, so teams can focus on the model and the application integration rather than server management. Consider an e-commerce checkout service sending each transaction to a fraud detection endpoint and receiving a prediction in milliseconds before approving the purchase. How might that affect fraud detection? Here's a pro tip. Use managed online endpoints for low latency, single record predictions like recommendations or fraud checks, and reserve batch endpoints for large scale, asynchronous scoring workloads. When deploying a model to a managed online endpoint, Azure Machine Learning supports two deployment paths. The fastest route is deploying an ML flow model, where the ML flow configuration, the ML model file, already contains the metadata, dependencies, and model interface needed for inference. So simply register the model, create a deployment, and attach it to the endpoint. If you are deploying a custom model, Azure ML needs more context. So you also provide the scoring script and the execution environment before creating the deployment. A registered ML flow model could be deployed to a managed online endpoint in just a few steps, allowing a checkout application to send transactions and receive real-time fraud predictions in milliseconds. For example, online payments. How could that benefit your organization? How do you validate and interact with a deployed managed online endpoint directly in Azure Machine Learning Studio? Consider these three actions: list endpoints, view endpoint, and deployment details, and test the endpoint. Use the Test tab of the endpoint page in Azure Studio and input data to test the real-time endpoint. A managed online endpoint exposes an HTTPS API for real-time inference. By pasting a sample payload and selecting Test, Azure ML sends the request to the deployed model and displays the prediction in the result pane, allowing you to verify that the endpoint and the scoring logic work correctly. You could test a loan approval prediction model and instantly see the predicted outcome returned by the endpoint. Always test endpoints with representative sample payloads, the same schema your application will send directly to the Azure ML Studio. This quickly confirms that the input schema, scoring script, and deployment are correctly configured before integrating the endpoint into your production applications. In this demo, we're going to deploy a trained model to an Azure Machine Learning endpoint, turning experimentation into something users and applications can actually consume. You'll see how a model becomes a live, scalable service configured with compute, authentication, and traffic handling, so predictions can be requested in real time. This is the critical transition from model development to production AI, where reliability, performance, and governance matter just as much as accuracy. Deployment and endpoint management are core skills in AI-300. So far, we've focused on training models and finding the best performer. But that's only half the story. A model that isn't deployed, it's just an artifact sitting in storage. In this demo, I'm going to talk about how to take a trained model and make it real by deploying it to an endpoint in Azure Machine Learning. This is the moment where the machine learning stops being an experiment and starts delivering value, where applications, APIs, and users can actually send data and get predictions back in real time or at scale. Now, I think it's also worth mentioning at this point, before we start the discussion about deployment here in our lab, is talking about registering your model. So right now, I have a model that I ran a little earlier, and you may remember it from a previous example, and I picked the model that ran the best. So I had a job and I picked the model that ran the best here. And so what I'm going to do is I could come in here and I could register this model. Now, it's wizard-driven, like many things here. The idea behind registering a model here in Azure Machine Learning is the process of really taking a trained model and saving it as like a first version inside of our Azure Machine Learning workspace. And when you register this model, especially an ML flow model, you're not just saving the files, you're capturing the model along with its metadata, metrics, parameters, lineage, and version history. And you're putting it in one space. So it really becomes a managed asset that you can keep coming back to and using. And there's a lot of benefits with this because we register this and then we have a different version that may come out. What we're going to want to do is we're going to want to keep this process so we can set this up very easily. And notice we have a wizard here, and notice I can pick my model type. And there's just a couple to pick from, and that's this ML flow. So you can see the ones that were registered here. And then there's this job output. What we're going to do is we're going to put some settings in here, and we're going to give it a name and what we want to call it, then the description and the version. So this will keep track of version control for us, as you can see here. And what you'll note with this, once we run through this process, is you'll notice that it's set to register it. And strictly speaking, you can deploy directly from training a model, but in practice, a lot of times, the registration is strongly recommended and could be considered really a best practice here for production. So we have a version of this model. And so when you do the deployment, it can be registered, and then you can also register it separately. And there's a lot of ways to approach this. And what we're going to do is I'm going to come back here, and what we just wanted to do is see what was registered here. And what we want to focus on after the registration is the deployment. So we have a model, and I can deploy it here. And there's a bunch of options we can choose from here. When we talk about deploying a model, this is the process of really just taking a trained model and making it available through an endpoint. So we can do this. Training answers that question, how does the model perform? What deployment answers is how do user applications consume it? So when we do a deployment, it will pick up the model, the environment, the compute will put it in at the endpoint for us. And we can use this for all sorts of reasons. But it enables us to do real-time predictions, batch scoring at scale, integration with other apps and APIs, Power BI pipelines, and more. And this is one of the reasons we are going to want to deploy this. And when we deployed it usually to an endpoint, as you can see here, some of the options I have, the first one is the real-time endpoint. That one is really best for low latency or on-demand predictions. With the other options we have here would be something like batch endpoint, and that's good for high volume offline scoring. And the other option is our web service, which is really kind of a legacy option for older deployment patterns like ACI or Classic. And so we have a lot of options here to choose from. And one of the options here we can choose is the real-time endpoint. Now notice when I do this, it gives us kind of a quick configuration, and it's going to deploy with 3 instances. Here we can see the virtual machine that you can pick up, and it makes some changes that you can see over here to the side where we can pick the machine we want to use, virtual machine. And so that option you can deploy with this new endpoint or an existing endpoint. And you can see what the endpoint name is and where it's going to be, and then the deployment name and what that's going to be called. Here's the address for that endpoint. And so it gives you a little bit more information here, and you can also scroll down and see a few more options. And we could choose this, and this would probably be our best way to go. And you could also go into more options, and you can run it through a wizard. But you will have more, have more selections if you can do it from this quick option. So what we could do is we could go back here and we could give it the ability to change out the compute type for managed Kubernetes, the authentication types, the notice, also the public network access as we want to make that available. You can put some tags in. There's the model here that was selected, the best model for the job. And then there's our deployment information. And you can see this gives you more configuration options than our quick option, like scoring timeout. You can turn on some of the disabled options here too. And then you can see a little bit more of the initial delay, the period, the timeout, the failure threshold. All those can be adjusted through here. And you can do some customization here by turning some of these options on or off. And so you can use this option. I could also go in and see the code environment, and I could load up my own script to customize it. So some of this gives you, you can see here more custom options. There again, in my virtual machine, I'm going to go ahead and choose this. And again, I can change it if I want. I can change the instant count. I can adjust it to the price point I want. And then I can note here, I can also see a little bit about the live traffic and enable mirrored traffic if available. And then from here, I can click on create, and I would have an endpoint. And so I would get a lot of information here when I do more custom. And so the quick is easy, but you don't get as many options to change. So going in a little bit more into more options gives you a little bit more to work with. So of course you can go in, you can try another one like batch endpoint. And this one takes us right into the wizard, and we can create an endpoint with this here. And then you can see too, we can adjust the tags on that. And it'll show the model that we've selected in our deployment. We have a name for it. We have an output also that we will work with here. And it's going to do the output action, append versus summary. Remember that this is batch. And then this is where I'm going to put the output file name here, the batch size, the scoring timeout, the retry numbers of instances. So you have a little bit more control with this one too. Also, what kind of logging do I want from this? And then the code and the environment again. And you can do this script, and then what you can do is you can tell it the compute, number of instances, which one you want. And this gives us simply the cluster for our compute. So we can set that up. Notice it will take us into the review here, and then we can deploy it when we're ready. So this could be a really easy way to set up an endpoint, but also to create a deployment that would go to that endpoint and then allow people to get connected to it. So the endpoint is the URL client that will call the deployments, and the deployments can change. And then what we really want to do here is we're going to create an endpoint so people can get connected to it. There's a lot of benefits with deploying this. Using an endpoint with this, of course, decoupling training from serving. Also, it helps support or enables our safe model iteration. There's a lot of good benefits that help us scale independently from training. It has production-grade security in it with authentication. So training builds intelligence, as you know, but deployment delivers the value. With Azure Machine Learning endpoints, your model is no longer just trained. It's production-ready, scalable, and ready to power real-world decisions. So training tells you which model works. Registration ensures you can trust the model and manage it and reuse it. And deployment is what turns that registered model into real business value. So we kind of get to see a little bit of it here. Hopefully you enjoyed this and got a lot out of it, and looking forward to seeing you in the next one. This hands-on exercise ties together the complete MLOps story in Azure Machine Learning. You'll walk through the full life cycle of a model, starting in development with GitHub Actions to automate training, then registering the trained model in a shared Azure Machine Learning registry so it's versioned and discoverable by your team. From there, you'll deploy the registered model to a production online endpoint where it can power real-time predictions. You'll also explore how teams monitor for model drift, retrain the model in development environment, and promote a better model version back to production. And if something goes wrong, you'll see how to safely roll back to a previous deployment and archive a problematic model version. In short, this exercise lets you practice the end-to-end life cycle of a production ML system: train, track, deploy, monitor, and recover, just like real teams managing AI teams in production. Now it's time for our knowledge check. Question 1. You've trained a model using the Python software development kit for Azure Machine Learning. You want to deploy the model to get real-time predictions. You want to manage the underlying infrastructure used by the endpoint. What kind of endpoint should you create? Answer: a Kubernetes online endpoint. Question 2. You're deploying a model as a real-time inferencing service. What functions must the scoring script for the deployment include? Answer: init and run functions. You've now seen how a machine learning model makes the leap from development into real-time decision-making by deploying models to managed online endpoints. Teams turn training results into faster, reliable APIs that applications can call instantly, bringing intelligence directly into user experiences and business workflows. This is where accuracy meets availability and where governance, scalability, and rollback matter just as much as model performance. With real-time endpoints in place, you're no longer delivering predictions. You're powering live systems that can respond, adapt, and improve safely in production as part of a complete end-to-end MLOps lifecycle. In this learning path, you moved from isolated ML experiments to production-ready AI workflows. You learned how to orchestrate pipelines in Azure Machine Learning, apply MLOps practices, automate training with GitHub Actions, and deploy and monitor models in production. What's your main takeaway? We learned that using both Azure Machine Learning and GitHub together can enable you to build, automate, and operationalize AI solutions so models don't just work in notebooks, they continuously deliver real value in production. Well, Learning Path 2 is a wrap. Thank you so much for watching. Remember that the learning doesn't stop here. Check out MS Learn at aka.ms/learn for even more AI topics and more. Consider visiting our AI Skills Navigator too for a finely curated and highly personalized learning experience. Looking forward to seeing you in the next video.